In today's class, we will study the analytical chemistry. It refers the test of cations, that is, for the practical purpose, for the point of observation. Questions are asked. What do you observe? What do you observe? Or in practical, you are asked to identify the cation based on the certain observation. Now, you will perform the experiment, you will have some visual observations, and accordingly you will find out that what type of cation is present in it. And if on the other hand, if you will find out the anion, you will be able to identify the salt. So, to identify the given salt in laboratory, we need to identify the cation and on the other hand the anion. Together they will give you the identification of salt. Now, so it is one of the important chapter or topic, that is analytical chemistry. Now, students, in this part, for the test of anion, we mainly use two reagents. One, the caustic alkali, NaOH, sodium hydroxide. We can also use potassium hydroxide for it, but potassium hydroxide is highly corrosive, highly reactive. So in place we prefer sodium hydroxide. But even if we will take KOH, the same observation will be obtained. So the one reagent is, so for this one, the reagents are NaOH, sodium hydroxide solution, and NH4OH, that is ammonium hydroxide solution. These are the two reagents used for the purpose of test of cation. Now we can study separately using this one and again using this one. But it is easier to study the test of cation by using both the reagents simultaneously for the comparison, that what change will take place when we use this one or when we use this one. So on this side we write using NaOH, and here we write using NH4OH. Now in the practical, suppose how will you proceed? First of all, in the practical lab, you will be provided with a little of sample of salt on a paper. How will you proceed? You will make its solution in distilled water in a beaker, like you see. Suppose this is a beaker. In a small amount of distilled water, we add the salt. Given salt is added to it. Here is the distilled water. So you make the solution. Then this salt solution is taken in a small amount in the test tubes. Suppose the test tubes are taken like this. Salt solution is taken here. And then you will add NaOH or KOH drop wise and observe, note the observation, note the changes taking place. So in first part, when we are going to study for the particular salt, then in first case, for first part we will write the step, what happens, how will you proceed, and then for the later on next part we will directly find the observation. Like suppose we are going to study for calcium ion, means suppose we are provided with calcium salt, then like this you will prepare the salt solution, take a small amount of salt solution in test tube and add drop wise NaOH. You will find the observation. So in first part we write here, that is NaOH is added drop wise to the salt solution, till in excess. Till in excess means when we add it dropwise, some changes will be observed, and after that, like suppose certain kind of precipitate is formed, then we'll further continue adding NaOH and we'll observe whether the precipitate is dissolving or not in excess of NaOH or NH4OH. So we write here NaOH is added dropwise to the salt solution till in excess. Now, what will be the observation? Here we write chalky white precipitate, chalk-like. Chalky white precipitate is formed which is insoluble in excess of NaOH. So this is the observation. Means you will get white precipitate. In board examination, you can directly write white precipitate, but in school examination, teachers also mark for this type of word, this kind of words. Like for calcium, it will be chalky white precipitate. So white precipitate will be formed, which will be insoluble, which will not dissolve in excess of NaOH. Now, what will be the reaction for it? Suppose we take calcium chloride solution in the test tube, add NaOH to it. What will be the product? Calcium hydroxide. This will be the white precipitate plus NaCl. So this is the white precipitate formed. Sometimes question is asked that name the compound present in white precipitate. Then you will answer calcium hydroxide. Again remember, if it is given name, then you will write in word calcium hydroxide, not the formula. Now, if for the same NH4OH will be taken, if we add ammonium hydroxide in the calcium salt solution, then there is no visible reaction, there is no visible change. So we write, sometimes often students, some people write there is no reaction, but how do we know whether reaction has taken place or not? So we say here no visible change. No visible change means there will be no change in it. So this is the test for calcium ion. Means with the help of this kind of observation, you will identify the calcium salt. Now take another part, another ion, another type of salt, salt of another metal. Now suppose we take Zn2 plus, that is for zinc ion. The cation, our cation is zinc, means we have the salt of zinc, like it may be zinc sulfate, zinc chloride or zinc nitrate. Always remember, there must be the salt which is soluble in water. Insoluble salt will not be taken for analytical tests. Now, we will write only observation because the step will be the similar. For the zinc, gelatinous white precipitate is formed which dissolves in excess of NaOH. Excess of NaOH. Now, how will it proceed? In this case, you see that zinc salt. When we use zinc salt, then gelatinous white precipitate is formed. Suppose we take zinc sulfate solution plus NaOH. It gives ZnOH whole twice, which is the gelatinous white precipitate, plus Na2SO4. Now the white precipitate is formed. But as we have studied here, discussed here, that this white precipitate dissolves in excess of NaOH. What is the reason? Now, zinc hydroxide is amphoteric in nature. Amphoteric means which react with acid as well as with alkali. So zinc hydroxide is amphoteric in nature. So it again reacts with NaOH and forms soluble salt, that is Na2ZnO2 plus H2O. 2, 2, 2. That is sodium zincate. It is soluble. Sodium zincate is soluble. So in this way we see that when sodium hydroxide is added to the salt solution of zinc, then gelatinous white precipitate is formed, which dissolves in or which is soluble in excess of NaOH. Now for this one, similar observation is obtained. The same change here also takes place. That is again gelatinous white precipitate is formed which dissolves in excess of NH4OH. Now on the similar basis we have reaction ZnSO4 plus NH4OH gives ZnOH whole twice, again white precipitate, plus NH4 whole 2SO4. So just you can see, like NaOH there is NH4 whole 2SO4, that is ammonium sulfate. Again zinc hydroxide reacts with more NH4OH and forms ZnNH3 whole 4 OH whole twice plus 4H2O. So this is a complex salt, that is zinc tetramine. Tetra for 4, amine. Here it is zinc tetramine hydroxide. So students, we see that there is a similar observation in using NaOH and NH4OH. So you will not be able to, that is there is a clear concept of it, that is in both the cases white precipitate dissolves in excess of NaOH or NH4OH. Now the third part is Pb2 plus. Like zinc, lead is also amphoteric. So in caustic alkali, it again gives white precipitate which will be soluble in excess of NaOH. So again this time, but there is another word used, Curdy. Curdy white precipitate is formed which dissolves in excess of NaOH. Now we write here, for lead we can use only lead nitrate, because lead chloride is insoluble, lead sulfate is insoluble, lead carbonate is insoluble. So we can use only lead nitrate for this reaction. So here it is lead nitrate solution plus NaOH gives PbOH whole twice plus NaNO3. But as we have written earlier, that is which dissolves in excess of NaOH. The reason is again the similar, that PbOH whole twice is an amphoteric compound, amphoteric hydroxide. So it again dissolves in alkali, forming Na2 PbO2 plus H2O. Sodium plumbate. So now you see, students, that caustic alkalis, that is KOH or NaOH, fail to distinguish between zinc and lead salts, because in both cases we get or they give white precipitate which dissolve in excess of alkali or NaOH or KOH. So caustic alkalis fail to distinguish between zinc and lead salts. Then how can they be distinguished? Then we use this part, NH4OH, in which for zinc there will be white precipitate which dissolves in excess of NH4OH. But for lead, again curdy white precipitate is formed which is insoluble in excess of NH4OH. Excess of NH4OH. So to distinguish between zinc and lead salts, we will use ammonium hydroxide. Again we will use lead nitrate plus NH4OH. Again it gives PbOH whole twice plus NH4NO3. So we can now distinguish between zinc and lead salts. Now we take another cation that is for analytical test or test of cation. We take another cation Fe2 plus, that is for ferrous salt solution like ferrous chloride, ferrous nitrate, ferrous sulfate. When we add NaOH, then dirty green precipitate, light green, dirty green precipitate is formed which is insoluble in excess NaOH. Suppose this time we use ferrous sulfate solution. We have to use ferrous Fe2 plus salt plus NaOH gives FeOH whole twice. This is a dirty green precipitate. So the compound present in dirty green precipitate is ferrous hydroxide. Same observation is obtained with ammonium hydroxide also. That is, it also gives dirty green precipitate. Dirty green precipitate is formed which is insoluble in excess of NH4OH. The same reaction can be taken here also, plus NH4OH gives FeOH whole twice plus NH4 whole 2 SO4. So this is similar in both the cases. Now we can have the fifth cation, that is the Fe3 plus or ferric ion. Fe3 plus. Again in this salt solution, when will you add NaOH? Then for Fe3 plus, reddish brown precipitate is formed which is insoluble in excess NaOH. Suppose we are taking ferric chloride solution. And if you add NaOH, then all these reactions are double decomposition reactions. Ions are exchanged here. So we have ferric hydroxide plus NaCl. Now this precipitate is insoluble in excess of NaOH. So just by observing the color of precipitate, you will be able to find out the metallic ion, the cation present in it. Now this was 5 number. Now Fe3 plus. In this case again you will have the same observation, that is reddish brown precipitate is formed which is insoluble in excess of NH4OH. So we see that in the both cases Fe2 plus and Fe3 plus, we have the similar observations in case of NaOH and NH4OH. Again we have the same observation, we have the similar type of results. So this was the fifth cation to be tested, that is the ferric. The last one, or generally we use these 6 mainly. These type of salts are given. Sixth, Cu2 plus. Pale blue precipitate is formed which is insoluble in excess of NaOH. Now pale blue precipitate is obtained, means it is cupric ion, Cu2 plus ion. Now suppose we take copper sulfate solution. NaOH is added till in excess we have CuOH whole twice plus Na2SO4. So we have pale blue precipitate which is insoluble in excess of NaOH. But there is significant observation with NH4OH, and this is most frequently asked observation in practical or in theoretical part also, paper also. Even in ammonium hydroxide chapter we also study this as an important equation or observation. Now pale blue precipitate is formed which dissolves in excess of NH4OH, forming deep inky blue solution, also called azure blue solution. This is the characteristic, that is when excess of ammonia is passed through or excess of ammonium hydroxide is added to the salt solution of copper, then pale blue precipitate is formed which dissolves in excess of NH4OH, forming deep inky blue solution. Even if in the question it is directly asked, what do you observe when excess of ammonium hydroxide is added? Then you will not write directly this line, but go through this, because first reaction will take place in little, then it will dissolve in excess. So the reactions are now you see, that is CuSO4 solution plus NH4OH gives CuOH whole twice plus NH4 whole 2SO4. Now this is the pale blue precipitate, but when in the test tube these two parts are present, we add more NH4OH, that is we are adding excess of NH4OH. So these are present in the test tube or in the beaker. and more NH4OH is added. Excess of it is taken. Then what will happen? CuNH3 whole 4 SO4 copper tetramine sulfate plus 4H2O is formed. Now this is the complex compound called copper tetramine sulfate. So this is the compound present in deep inky blue solution or azure blue solution. Now, so students, you are now able to find out the the cations present in the given salt. It will help you in practical, it will help you in answering, identifying the cation in the given salt, and you will be able to answer different observations, objective questions also. Clear? Students, I think it is quite clear to you. Now, if you like this teaching, our classes, our method, a way of explaining the topics, then like, share and subscribe our channel. Press bell icon to get the latest videos uploaded by us. Thank you.